Hi, welcome back. In the last lesson, I did an informal discussion of how to apply this. So in other words, the first method is, can I apply formulae directly? So the title will change obviously. I can put it as method 1. When can you apply the standard formula? Directly. When can you apply the standard formula directly? Can I apply the formula directly? Yes and no. Suppose I had integral 3x minus 1 power 4 dx. Yeah. This resembles x power n. But it is not x power n. I have 3x minus 1. So in other words, you compare with standard formula. That's what I said. Resembles x power n. Then what you do is, notice or note down, you can write down or mentally note down the difference. What's the difference? The difference is there you had x, here I have 3x minus 1, there you had a power n, here I have power 4. So n is 4, that's fine. But the variable x is 3x minus 1. In other words, x has become 3x minus 1. Then what you do is find the derivative of the difference you notice. What do I get when you differentiate this? I get 3. The question you ask is that a constant? Yes, it's a constant. If the derivative of the function you have noticed, in other words, see if the question resembles the formula. Yes, it does. Then if it doesn't resemble, what exactly is the difference? How do you say it resembles? Because look, is something power n, only thing is in place of x, I have 3x minus 1. Good. Your notice is 3x minus 1. So differentiate 3x minus 1. What do you get when you differentiate 3x minus 1? You get 3. The answer you got, is it a constant or a variable? It is a constant. If it is a constant, apply formula. Like we did in onion rule. So x power 4 gives you x power 5 over 5. So 3x minus 1 power 4 gives you 3x minus 1 power 5 over 5. I have done the integration, but what was the constant you got? 3. Divide your answer by the constant you got on differentiation. You understand that? So I'll do more questions. So when can you apply the formula directly? If the question you have resembles a standard formula. Fine. So first question is, does it resemble a standard formula? Yes, it does. Is there, what's the difference between the formula and what you have? You notice that? Whatever is a different function you have noticed, differentiate that. If you differentiate it, do you get a constant? If you get a constant, apply the formula, write the answer, and in your final answer, divide the answer you got by the constant you got from differentiation. Of course, many textbooks and teachers say integral ax plus b power n is ax plus b power n plus 1 over a times n plus 1. Yeah, you can keep that formula. Then you'll have the same for sine kx, then you for cosec kx, then you do for... So how many formulae will you remember? Instead, stick to one set of formulae and apply the rules, right? That logic will help you, especially when it comes to substitution, trigonometry, and so on. So I would prefer this method, but if you're not comfortable, stick to the formula in your formula book. Nothing wrong. Okay, let's take some more examples. Suppose I had integral 1 over square root 5 minus 4x dx. I could write this as integral 5 minus 4x power minus half dx. That resembles x power n, isn't it? Something power n. What's the difference? 5 minus 4x. So find the derivative of 5 minus 4x. What do you get? Minus 4, a constant. If it is a constant, apply the formula directly. So look, x power n gives you n plus 1 over n plus 1. So x power minus half gives you power minus half plus 1 over minus half plus 1. That takes care of the integration. But when you differentiate it, you get a constant minus 4. So multiply by minus 4 at the bottom, or divide your answer by minus 4. That becomes square root of 5 minus 4x over 1 minus half is half. Half of minus 4 is minus 2. So minus 2 plus c. Understood? Okay. Let's take more examples. Don't worry. Suppose I had integral 7 e power 5x plus 1 dx. Number 1, kf of x, remove any constant you have outside the integral. So first job I'll do is 7 integral e power 5x plus 1 dx. Very good. Now this resembles e power x, but it is not e power x. It's e power 5x plus 1. So what's your extra function? In place of x, I have 5x plus 1. Differentiate 5x plus 1. If you make it a habit of writing this way you will not go wrong. So compare the question with the standard formula. If it resembles a standard formula, notice the difference, differentiate the difference. The answer is a constant. I can apply the formula directly. So it becomes 7 times e power x gives you e power x. So e power 5x plus 1 gives you e power 5x plus 1. But divide your answer by the constant. So over 5 plus c. Many a time when I mark tests and exams, especially when it comes to e power minus 2x, students would write e power minus 2x divided by 2. For some reason, that minus sign seems to vanish. Whereas if you write like this and do it, it might take one extra step, but you will not go wrong. Okay? Ultimately, the other thing that will happen is, however big the question might be, with all the substitution, different methods, everything, it will come down to one of these formulas. Yeah? The whole of integration, you are looking at ways and means of bringing it to the standard format. Okay? Let's take another example. Integral ln 3x minus 1 over 3x plus 2 dx. Whoops. So you, oh, not ln. I'm sorry. Integral 1 over 2x minus 3 dx. I'm taking simple example, sorry. So now, this resembles 1 over x, but it is not 1 over x. In place of x, you have 2x minus 3. So what is derivative of 2x minus 3? Is 2, which is a constant. So integrate directly. 1 over x gives you ln x. 1 over 2x minus 3. We normally put a modulus to be on the safer side. I have done the integration. But when I differentiated, I got 2 as a constant. In integration, you divide by 2. Got it? Okay. Suppose I had integral 3 cosec squared y over 6 minus 4x minus 6x. First and foremost, the 3 which is inside, take it outside. Let's make it 2x. Why bother? Minus 2x dx. Or shall we make it 3x? Okay, minus 3x. Alright? This resembles cosec squared. But in place of x, I have pi over 6 minus 3x. So therefore, find the derivative of pi over 6 minus 3x. Remember, pi over 6 is a constant. So therefore, minus 3 gives you minus 3, which is a constant. Therefore, since the derivative of the extra function is a constant, I can integrate directly. So minus 3 cot pi over 6 minus 3x. Like we did in differentiation, x squared gives you 2x, y squared gives you 2, y sine squared gives you 2 sine. Of course, there we had the cos and everything else. Having done the integration, divide your answer by the derivative. So your answer is cot of pi over 6 minus 3x plus c. Right? So I am trying to take some examples to show you how you can, or suppose you're given, let's say, given that gradient of a curve is dy by dx equal to x power 3 over 2 plus 2x power half minus 3x whole over root x, 3x plus 1 over root x. Okay. Given that when x is 1, y is 2, find the equation of the curve. In the form y equal to f of x. By the way, I have an equation which has dy by dx. We'll do it in more detail later. That's called any equation that contains a dy by dx is called a differential equation. Okay. So, y will be integral dy by dx plus c. Don't forget the plus c, of course, dx. Because integral of dy by dx with respect to what? With respect to x. The dx means you are integrating with respect to x. So that gives you y equal to, look, I can't integrate this directly. X power 3 over 2 divided by x power half plus 2x power half divided by x power half plus 3x divided by x power half plus 1 over x power half dx. So that becomes integral 1 1/2 minus half is 1 plus 2 plus 3x power minus half plus x power, x power half plus x power minus half dx. Right? In other words, you simplify each of the terms. So let me write it here because I don't have space. When I integrate x, so y is equal to, when I integrate, remember this is a plus c. This is x squared over 2 plus 2x plus 3x power 3 over 2 divided by 3 over 2 plus x power half divided by half plus c. Straight away put x equal to 1, y equal to 2. So 2 equal to half plus 2 plus 2 plus 2 plus c. Look, half, 2 times 1 is 2, 3 cancels, 2 goes up, so that's 2. That's 2. Here 2 goes up, 1, so that's 2 plus c. So 2 and 2 cancels, 4 and a half. So c is minus 9 over 2. So y equal to half x squared plus 2x plus 2x power 3 over 2 plus 2 root x minus 9 over 2. At this stage, this is called a general solution. Why a general solution? Because we have the constant c. The constant c is called an arbitrary constant. That means I don't know the value of c. Arbitrary. I don't know. So therefore that, and then if you're asked to find the equation of a curve, we use these values. These values are called the boundary conditions. So you use the boundary conditions to find the constant c. A function with the constant c evaluated, that answer is called a particular solution or a specific solution. Remember, I told you in the beginning, when you say a curve has gradient 4, there are infinitely many lines with gradient 4. But I want only one of them. Similarly, some function has all these gradients. I want only one of them which passes through a certain point where 1 and 2. So you find a specific solution. So to recollect, you can apply the standard formula provided the question you have, the extra function you have, when you differentiate, you get a constant. You cannot apply the formula if you don't get a constant. So what happens, sir, if I don't get a constant? We'll take it up in the next lesson, the next method. Okay? Thank you. Bye-bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded, and launched. Thank you very much.